Good morning. We're going to do a little information about confidence intervals today. That is, we're going to start chapter 8. And chapter 8 is all about what's called confidence intervals. And there are three main ideas in chapter 8, but they all have to do with this thing called a confidence interval. A confidence interval is an interval, so it's got a lower bound and an upper bound. And what we're doing with this confidence interval is giving some information about our population mean. We're pretty sure our confidence interval contains our mean. That is, the population mean is in between this lower bound and this upper bound. Now, how sure are we? Well, that's what the percentages are for. Common percentages that are attached to these confidence intervals are 90%, 95%, 99%, although any percentage could be used. We could use 25%, but to say I'm 25% confident that our population mean is in between these two values, that doesn't inspire very much confidence. The exact opposite of what our confidence interval is supposed to do. So what we're going to do in chapter 8 is calculate these lower bounds and the upper bounds. It involves something called a margin of error, which some of you may have already heard of. Now, what we do to calculate these confidence intervals is we use this formula that you see here, x bar plus or minus z times our standard deviation of x bar. X bar, remember, is our sample mean, and it's called the point estimate. If we just wanted a single value estimate of our population mean, we could use a sample mean. That wouldn't be a very good estimate, but we could do it. Instead, what we do is we create this interval. And the interval is created by taking our point estimate, our sample mean, and adding what's called the margin of error to get our upper bound, and subtracting the margin of error to get our lower bound. Our margin of error is calculated by taking a z-score times the standard deviation of x bar. Notice that capital E is our symbol for margin of error. Now, where do we get the z-score? Well, the z-score is tied directly to our percentage. Now, the 90%, 95%, think of that as coming out of the middle of our picture. So here we have our pictures, and you notice on a 90% interval, we have two tails. I've colored them purple. And because the entire area is 100% minus 90% leaves us with 10% that has to be split evenly in these two tails. So each tail contains 5% of our area, or 0.05. That 0.05 is what we use to find our z-score. So we'd use inverse norm, or we'd use the normal distribution dot inverse CDF on Desmos. We've got something similar going on with the 95% confidence interval and the 99% confidence interval. Those percentages come out of the middle, and to find z, we need to know how much area is left over in these tails. So once again, here's our formula. X bar plus or minus z times the standard deviation of x bar. So our sample mean, our point estimate, plus or minus our margin of error. Now, we can only use this in certain circumstances. If we don't know the population standard deviation, we cannot use this formula because we won't know how to calculate the standard deviation of x bar. It doesn't matter if our sample size is small or large, and I can have a population that's normally distributed or not. So kind of a wide variety of times we can use that, but we have to know the population standard deviation. Here's problem number 11 from page 348. I've got a sample size of 20, a standard deviation of 3.1, and a sample mean of 24.5. So part A, what's our point estimate? Well, since our population mean is 24.5, that is what our point estimate is. So to estimate the sample or the population mean, we would just say, well, our sample mean is 24.5, so we'll estimate our population mean at 24.5. To make a 99% confidence interval for the population mean, we take our 99% out of the middle. That leaves us with 1% left over, but it has to be split evenly in these two tails. Now we're going to use inverse norm, or we can use Desmos to find our z-score.